Elasticity of demand shortcut formula. There are three methods to measure elasticity of demand. They are percentage method, total outlay method, and point method or geometric method. Now, suppose you are facing a question like this. Of the 2 points Q and R, in which point the elasticity is more? The two demand curves are parallel. We have to find at which point elasticity is more. Good. Look at this. Compare the elasticity at points Q and R. Here, the demand curves start at the same point on the y-axis, but have different slopes. We have to compare the elasticities. This is yet another case. See this one. Compare elasticity at point R when it is on the demand curve AC and when it is on the demand curve BD. Demand curves with two different slopes cut each other at point R. We have to find elasticity at point of intersection with respect to the two demand curves. In such cases, which method will be used by you to find the correct answer? To be honest, none. It is very unfortunate, but we have to find the correct answer anyway. How? This video suggests to use the vertical axis formula. Then what is vertical axis formula? This is what we are going to discuss here. Look at the demand curve AD. It is a straight line demand curve. How to measure elasticity at point R using geometric method formula? It is so simple. Immediately we use the formula length of lower segment of the demand curve RD divided by the length of upper segment of the demand curve RA. Now, this is the vertical axis formula PO by PA. It is so simple. We can arrive at the same answer by using this formula. It is very useful in solving the already stated problems. Let us use numerical values to understand this. Let the length of the lower segment be 12 centimeters and that of upper segment is 6 centimeters. Then elasticity at point R is 12 by 6, 2. Demand is relatively elastic. We shall turn to the vertical axis formula. The length between P and O is 6 centimeters and between P and A is 3 centimeters. 6 divided by 3, 2. We get the same answer. There is geometric proof for this. I shall give it in a separate video. Those who are interested shall view it. To face the competitive examination, the functionality of the formula is more than enough, because no question will be asked on geometrical proof. After having learnt the formula, we shall proceed to find the answer for the already stated questions. First, we shall take the two parallel demand curve question. Applying the vertical axis formula, the elasticity at point Q on the demand curve BC is PO by PB. Elasticity at point R on the demand curve AD is PO by PA. From the observation, we can easily understand that the length of PO in both the ratios are the same, but the length of PA is greater than the length of PB. Of the two denominator values, PB is less than PA. So, the value of PO by PB must be greater than PO by PA. Our conclusion is that elasticity at point Q is greater than at point R. Option A is the correct answer. In the second case, the slope of the demand curves BC and BD are different, but they start at the same point on the y-axis. Let us compare the elasticity at points Q and R. Using the vertical axis formula, elasticity at point Q is PO by PB, and at point R is also PO by PB. Both the ratios are the same. So, elasticity at point Q is equal to the elasticity at point R. Option C is the correct answer. In the last case, demand curves AC and BD with different slopes cut each other at point R. We shall examine the elasticity at point R with reference to the two demand curves. Take the demand curve BD first. With reference to the demand curve BD, elasticity at point R is PO by PB. With reference to the demand curve AC, elasticity at point R is PO by PA. The denominator value in the case of demand curve AC is PA. It is greater than PB. So, ratio PO by PB is more than the ratio PO by PA. Hence, elasticity at point R on the demand curve AC is less than elasticity at point R on the demand curve BD. Option B is the correct answer. Based on the above discussion, we shall arrive at the following conclusions. These are going to be your real shortcut to find correct answer in the competitive examination. 1. If the two demand curves are parallel to each other, for any given price, the elasticity on the inner demand curve is greater than its corresponding point on the outer demand curve. In short, the inner demand curve represents a higher elasticity. 2. If the two demand curves start at the same point on the y-axis, even though they have different slopes, for any given price, elasticity on the inner demand curve is equal to its corresponding point on the outer demand curve. 3. If the two demand curves with different slopes cut each other, for any given price, the elasticity of demand on the curve, which is relatively flat, is greater than its corresponding point on the demand curve, which is relatively steep. In short, the relatively flat demand curve represents a higher elasticity. These are the key points. Use them to your advantage. Our discussion ends here. We shall meet in the next lesson. Vanakkam.